by Venom on instrumental backups in Kubernetes, where we stand and what's missing. So in this talk, he will be comparing different strategies used to protect Kubernetes stateful application data, and also he will be discussing about the block tracking in Kubernetes.
I hope I'm audible. All right, let's get started. My name is Prasad. In the next 30 minutes, I'll try my best to not bore you or make you feel sleepy. I'll also talk about the incremental backups in Kubernetes, where we stand and what's missing. As you know, my name is Prasad. I work for this amazing organization called Kasten by Veeam. I like working on Kubernetes, Golang, and open source. I'm also the creator of BotCube and actively contributing to Canister. I would love talking about cricket and trekking. If you meet me, I can talk about this all day. In this today's talk, I'll brush up on few concepts like stateful set, how the volume is provisioned on Kubernetes. I'll also talk about CSI in very high level. Then, since this talk will be around data and managing data, protecting data, I'll also talk about why we need data protection approach for Kubernetes, what's available there, what are the different APIs available to achieve the same, and what are the building blocks those are missing in Kubernetes. I'll also talk on very high level about the KEP that we are working on. It's about adding change block tracking functionality to Kubernetes. All right, so what are stateful applications? The application that needs the state to be persisted to operate. Database is the simplest example. Each transaction depends on its previous transaction, so the data needs to be persisted. On Kubernetes, we deploy stateful applications using stateful workloads, and along with the volumes, obviously. All right, so how we provision volumes on Kubernetes? There are two ways, basically, static provisioning and dynamic provisioning. We'll mostly talk about dynamic provisioning due to the scope of this talk. All right, so admin basically creates a storage class. Storage class has all the information about the provisioner. And then as a user, when you create a PVC, the controller looks at the spec. It finds out what is the storage class available. Storage class requested for the PVC. Kubernetes knows which volume provisioner to call. It asks the provisioner to create volume for it, and then the volume basically gets created. The provisioner could be anything. It could be Google Cloud or AWS, EBS, or DigitalOcean. And then it mounts the PVC to pod. All right? There are few examples of how the resource manifest should look like. I won't go into the detail. So how Kubernetes talks to these different storage providers. It doesn't have like all the switch case, like if it's GCP, then call GCP APIs. It's not like that. This can be achieved, or this is possible because of CSI. CSI, if you're hearing for the first time, it's content storage interface. It's the interface or set of rules through which any container orchestrator talks to the storage provider. Okay, so it also decouples the functionality of core container orchestrator from the storage management, and it also allows different storage providers to develop their own plugin independent from the Kubernetes components, let's say. Since we are talking about the data, so what exactly is data protection in Kubernetes term? When we say data protection, it's just backup restore, right? But that is, in Kubernetes, it's not just volumes we have to backup. Along with data, Kubernetes app consists of different configuration. For example, if you have workload is deployed using stateful set deployment. You create your application's configuration using config map resources. If there is sensitive data, you obviously use secrets to do the same. And there are a bunch of custom resources to satisfy your different use cases. So all these components, along with the data, the Kubernetes configuration plus data makes a Kubernetes app. And this app needs to be backed up as a single unit. So when we talk about data protection in Kubernetes, it consists of backing up all these components And the end result is we call it backup. Why do we need data protection? If you're adventurous, you won't need it. You let the disaster happen. But yeah, I mean, if you like to live dangerously, you don't have to listen about the next things that I'll be talking about. All right, I'll also take this. I'll also will like to talk about the data protection working group. So if you are around Kubernetes communities, or if you have joined Kubernetes Slack, you might know there are different SIGs in Kubernetes, different community groups. We also call it special interest group. There are groups for groups like SIG storage, which specifically focuses on storage. There's SIG API machinery. Along with SIGs, there are working groups. These are again community groups where a bunch of people collaborate with each other and propose new features to the Kubernetes. So data protection working group is another Kubernetes community group where the folks from different SIGs, as well as leading different folks from leading disaster recovery solutions, work together, find out what are the missing components in Kubernetes to promote data protection, and work towards designing and proposing the new features. It collaborates with different SIGs, and there is an interesting white paper. I would really recommend whoever is interested in storage and protecting data. I would encourage you to go through this white paper. There are very interesting insights listed there. All right. So why do we need new data protection approach for Kubernetes? Why the traditional approaches or traditional solutions won't work in Kubernetes? There are different reasons. First is how the application how the application architecture has evolved over time. So if you look at the timeline, we have witnessed how the application architecture has evolved from mainframes to client service-based architecture, virtualization, and then we are here in the cloud native era, where everything is distributed, everything is dynamic and short-lived. So the strategies strategies and solutions which were kind of created by taking the monolithic applications in mind, they don't work considering the dynamic and distributed nature of current architecture. Before the cloud native approach, before the cloud native infrastructure, though the application architecture has evolved, but the paradigms to protect the data, that remains constant. With the cloud native architecture, now the data is kept separate from the workloads. All we have is just the metadata information about how the application is run, and let's say few references to the storage, the addresses to the storage. So that's why we need a new data protection approach, which takes all the advantage of this distributed cloud native technologies, cloud native architecture, and have the Kubernetes native, cloud native solution. We also seen the rise of stateful set application. So it's said that when containerizing technology was taking off, the container were supposed to be ephemeral. People were supposed to run only stateless apps on Kubernetes, on containers. People didn't think there would be need of running data and protecting data on the containers. But now, as we see, if you say at the modern stack of application, we cannot just divide the application, Kubernetes application, into whether it's stateless or stateful. There will always be, few parts would be stateless, few parts will be stateful, and bunch of other things like configuration, how you provide configuration to Kubernetes app and secrets and all those. So, as I said, everything needs to be considered as single application, and there has to be an approach which treats all these components as a single Kubernetes app or single Kubernetes unit and protect that. All right, so how do we achieve data protection in Kubernetes? What's available as we are talking today? There is volume snapshot APIs released in Kubernetes 120. You might have used volume snapshot APIs to snapshot volumes. There are different APIs to get manifesto of different workloads, like stateful set or any Kubernetes resource. You can get state of or manifest of it using Kubernetes APIs. There are also CRDs, which gives you idea about the definition of application in case of custom resources, let's say. All right, so what's missing? Again, we are not reinventing the wheel here. There are already a bunch of disaster recovery solutions available. Each one uses different approach to protect the data. But these are like the building components when we talk about data protection in general. I'll give you an example. Like before the volume snapshot API was there, there were backup solutions. There were different disaster recovery solutions which were there to back up and restore your Kubernetes data. But before CSI, before we had the interface, each one has to figure out what kind of provision is there, have these switch cases, have these if-else conditions. With the volume snapshot API, it made the backup client lives very easier to just call a single interface and snapshot the volume. It doesn't matter what is the provisioner, what are the backend storage provider behind it. Okay. Again, all these components we'll be talking about. There are backup solutions which achieve the same using their custom logic, but these are the building blocks which has to be present in Kubernetes to work, to have the efficient approach towards the data protection. Okay, so volume backups is one thing. Backups and snapshot are used interchangeably, but both has different volumes when you talk about data protection. Snapshot means creating a point-in-time recovery of your data. Backup means copying your data and storing into somewhere else than your cluster, so that whenever, and then it has the different life cycle from your cluster, so that even if your cluster messes up, you still have a location from where you can import the data and restore that. To use volume backups, you'll obviously need to specify the location. So there should be an API in Kubernetes which allows us to set the location through which we can provide the location information, right? Volume populator, again, one of the missing building block in Kubernetes to create the volume with pre-calculated data, let's say, predefined data. QSing and unQSing hooks. Anybody working as a DBA or have worked on database backup restore, they might know, like, when we need to back up database, the snapshotting the volume isn't enough. The backup has to be application consistent. And the way to do that is we quest the database, basically. We snapshot the volume or do the backup with whatever strategy, and then we unquest the database so that the backup is always in the consistent state. So right now, there is no way in Kubernetes to achieve the same. Change block tracking to get the information about what has changed between two snapshots, that I'll be talking in detail in the next few slides. There should be a way in Kubernetes to achieve the same. Grouping volume and taking snapshot of the group. Again, application backup and application snapshot and backups. An API to do that. Right now, in Kubernetes, there is an API to snapshot volume. But as we discussed, the app consists of application data as well as application resources. And there is no API to snapshot your application resources. All right, so let's put all the missing blocks in place, and let's see how the ideal end-to-end workflow for backup looks like. Okay, I'll explain the color codes first. The orange ones are the missing components in Kubernetes. The green ones, which are the APIs already available in Kubernetes. The yellow ones are something which in progress, whether it could be in design phase or implementation phase or in alpha phase. All right, so let's imagine we have an application and we want to back up that. So it starts with application backup API. The API will figure out what are the different resources we need to back up, and the PVCs need to back up, or the data that needs to be back up. So, all right. So for the backing up Kubernetes resources, the Kubernetes already has the API to do that. We dump the specs, and we using the backup repository, we push the metadata to some object storage. For data backups, if it's native, we dump the data and we export that. If it's not native, we snapshot. Again, for snapshotting, we quest, snapshot, and then quest the volume. We use volume snapshot to snapshot the PVC, and then volume backup API to basically export all the data to some storage. All right, same workflow with restore. We have. It starts with application restore API. We get all the metadata, all the information, all the data from the backup repository. We recreate the resources. After recreating resources, Kubernetes resources, we store data. So we have application and data in place. We have stored the state. While storing the database again, if it's native, we directly copy the data from backup repository to the PVC. If it's not native, we recreate the PVC from the volume snapshot. And if needed, we, using the volume backup API, we copy the data. All right, so let's talk about change block tracking. What does it mean? Again, if anybody is working in storage domains, they might know change block tracking is nothing new. It's a way to get the information about. It's a way to get the difference between two snapshots, basically. So we talk about incremental backups. Let's say we have taken a snapshot of file system which has 1 TB of data. For the subsequent backups, when we talk about incremental backups, it doesn't make any sense to copy the whole data each time. So let's say there is 1 TB of snapshot we have already taken, and we have just changed a single file or multiple files. The change could be in KB or MB, but to do the incremental backup, it doesn't make sense to copy whole data just to back up these MBs of change, right? So change block tracking is a way to get the block information, to get the information about blocks which has changed between two snapshots. Again, if you have read about storage, when we store data on any storage, that gets divided and stored into blocks, okay? So when we compare two snapshot, we should get, if you get information about which blocks are changed, let's say 100 and 200 block has changed, then you can just locate those blocks, get the data, and just use that data to backup. That improves the incremental backup very significantly because we then know which data to backup instead of copying whole data each time. All right, so let's put this CBT feature in our backup workflow. So how would that look like in Kubernetes? So Datamore Pod is our business logic, or I would say backup client, which is responsible for backing up the PVC. Now we have application which has PVC, PV, and local and the block disk in the backend. It has already created a snapshot 1. Now we want to do the incremental backup, right? So it will create the second snapshot. We call it snapshot. Let's name it snapshot 2. Now, using the CBT service, we'll request to the CSI driver to compare these two snapshots and just give me information about which block has changed. So the backup client would get information of which blocks has changed. Let's say first block, 100 block, and 200 block has changed. Then the client would look for those blocks in the disk, copy the data from it, and just get the data from it, and just copy those data to the backup storage. So yeah, this is how the incremental backups will be improved significantly if you have the change block tracking mechanism in place. Okay, so we are working on designing this new feature in Kubernetes. KEP, if you're working the word first time, it stands for Kubernetes Enhancement Proposal. So I with couple of folks, we are working on proposing design to achieve the same feature. The primary goals we have for this feature is to propose changes in CSI so that the CSI driver will implement the same and get the change block information. We don't want to compromise on scalability. Since the response of this API could be very huge, we don't want to disturb any Kubernetes internal, we don't want to we don't want to impact any Kubernetes component since the lots of traffic will be moving here and there. So these are a couple of things we have to keep in mind while designing this feature. We don't want to compromise on security as well. Due to the time limit, I can't go into details of the design, but if you're interested, I have put down the links about the proposal and the CAPE. The complete design you can see on this reference. There's an end-to-end working prototype as well we have developed. Right now it's in the phase of, I would say it's approved by the working group. Now we have to get it approved from CSI community as well as the Kubernetes architecture community. SIG arc, we call it. All right, so is it visible? The text is visible? Okay. So I cannot discuss in detail about the new feature we have proposed, but I can just on very high level can talk about how the client workflow would look like with the feature in place. So we are proposing the change block information in two parts. The process will be in two parts. First is the client would create a session. The session will consist of the information about for which snapshots you want to create the session. There will be a controller which validates the client, do all the authentication, authorization checks, creates the session, and returns session parameters in the CR. So once the client gets the session parameters, with the session parameters, you'll also get a URL through which you'll get the change block metadata. So the client with the session parameters will call the gRPC endpoint of the proxy service, and the proxy service will call the CSR drivers API to get the change blocks and return to it. Yeah, so it will be two-hop process. The reason why we had to keep the actual gRPC call from Kubernetes resources, there are a bunch of reasons to that. We cannot store the change block metadata into the status of the resource because it would consume lots of etcd. And as I already mentioned, since the amount of response or the size of response would be too huge, it could be in GBs or TBs. We cannot afford flowing that much data through Kubernetes APIs. So that's why we had to decouple these two calls, but we also had to make sure that we don't compromise on security. If you're interested, you can catch me. We can discuss about the detailed design that we have proposed. And I have already shared the links in the references. Yeah, if you like to know more, feel free to chat about it with me. If you like to contribute, you can join the working group meetings. We have alternate Wednesday. If you want to provide any feedback or help us with new features and designs. Yeah, that's all I had to share. Any questions? Yeah, yes, please. Can you get a mic? So there's a difference between snapshot and backup. Snapshot means creating point-in-time recovery. It's local. If your volume is lost, you cannot restore it. If you have a backup where you export the data to some object store, even if your volume gets deleted, you can still use that exported data to import and recreate your state, basically, right? The snapshot restore is to snapshot the volume. To restore it, the volume has to be present, the source volume. Yeah, that's the difference. And when you talk about backup, it's about copying the data to somewhere else. And when you talk about incremental backups, we need to know what needs to be copied instead of copying whole thing again and again, right?
Tapio that was presented, I forgot the name.
Copia, yeah.
That does backup or
That does incremental backup. It internally uses different hashing and different algorithms to do the same. But yeah, there are different tools you can use, different scripts you can use, but there is no Kubernetes native way to achieve the same. And with this, we are, since we are proposing this change in CSI, all the storage vendors will implement this feature internally. And as a client, you just request to the CSI driver, and it will get you the data. It creates a unified interface for the clients. All right, thanks all. Thanks for having me.
Prasad, would you please wait? Thank you for the insightful talk. I would like to call Vishal to felicitate Prasad with token of appreciation. Thank you, Prasad.